All right. I've already drawn a 555 Astable mode circuit here in PSpice. And let's look at what we got going on here. We got a voltage source over here. We got a capacitor over here. We got a couple of resistors and a capacitor here. If you look, I've got a probe attached across this 10K load. That's pin 3 on the 555 timer, and I've got C1 attached here, which is looking at what's going on across the capacitor C1 here. So what this thing is doing when a 555 circuit is running in astable mode, it's producing an oscillator circuit, and what you can do is you can generate some pretty accurate free running waveforms. And those waveforms, the outputs can be adjusted excuse me, by means of an externally connected RC tank circuit. Okay, in this case our tank circuit is R1, R2, and C1. That's our little tank circuit here. By making some adjustments in here, we can adjust what the output is going to be, okay, across the load here. So if we take a look at what's going on, okay, and this will be done, this is done as part of a lab. So in my class anyways, we would have already have discussed this in class and looked at how this thing works. Well, what happens, without getting into the specifics here, C1 is going to charge through R1 and R2. And the way it's hooked up, it's only going to discharge through R2. And what that allows you to do, it allows you to vary the duty cycle between 50 and 100% just by changing the value of R2 here. Now, I could have put a potentiometer in here instead of just a resistor. I've got a 500 ohm resistor in this thing right here. So if we decrease the value of R2, the way this thing works, and we'll take a look at some outputs in a minute, the duty cycle is going to increase towards 100%. And by increasing R2, if we make R2 bigger, the duty cycle is going to drop, and it's going to drop to 50%. It can't go lower than 50%, the way I've got the circuit set up right here. There's a way to get lower than 50%, and I've got D1 and D2 here. We'll talk about those in a minute, but I just put these as notes just so I remember to discuss them here. But basically, if R2 is very large compared to R1, the output is going to be determined by R2 and the capacitor only. And again, the problem with this configuration is that the duty cycle will never go below 50% because the presence of R2 prevents this, basically. Okay, and what that means, duty cycle, you can't make the output on time shorter than the off time. So what do we do? Well, let's run it here first. Let's make sure what we're saying is true. I'm going to make R2, I'm going to change R2 here. We'll start with a bigger resistor first. I'm going to make it 10K. And we're going to run it. Okay. Oops, didn't go. 10K. So 10K ohms. Okay, R2 is bigger than R1, twice as big. Okay, let's see what happens. Run it. Let's look at our output and input here. You can see the red probe is C1. That's the capacitor charging. Green is the output across that load resistor. Okay. So what do we got? Let's take a peek here. Okay. R1 is 5K. R2 is 10K. I've already done the calculation on this one. We got around a 60. So I got 59.7%. That's our duty cycle. Okay, so 59.7% of the time the signal is high, and the remaining, what is that, 40.3%, the signal is low. Okay, so and what did we say? If we decrease the value of R2, the duty cycle should increase towards 100%. So let's make R2 now 500 ohms. See what happens. So we've changed it. Let's run it. Let's look at what we're getting here. Oh, wow, look at this. The signal is very high. It's high most of the time. It's only low for a very little sliver of time here. I've done the calculation on this one, and I'm getting 97.3% is the duty cycle. So 97.3% of the time this signal is high, and it's only low, what's that, 2.7% of the time. So it works, okay? So we had mentioned there was a little problem with this, though. We said the duty cycle will never go below 50%. And the presence of R2 prevents this. So what do? We connect the signal by passing diode in parallel with R2. So I'm going to go back to my circuit here. So I'm going to grab a diode. Oh, it's right here. I'm going to put D1 here, and I'm going to throw D2 over here too. Okay, so D1, D1 we're going to put in parallel with R2, okay, and it's going to be facing in the downward direction. I got to rotate this thing. If I can click it right, here we go. Click R. So we want the cathode at the bottom, the anode at the top. If you look at a diode here, the little line is the cathode. The arrow, the other side is the anode. Okay, if you're looking at an actual physical diode in the lab, the stripe, there's a little stripe on diodes, and you'll see the stripe is on the cathode. That's the stripe. So we're going to take D1. I'm not going to hook it up. This is what I have the students do. Say, okay, stick D1 in parallel with R2. Make the connection, run it. What happens? Okay. So you also have the option of taking D2 here. If I can get it. Come on. All right, so let me rotate it. Okay. If we stick D2 oriented with the cathode in this direction in series with R2, we connect it right here, the other side of R2, and let's start juggling some resistor values around, and let's see what happens. Okay. So, and what that does, basically, if you connect by connecting D1, the in parallel with R2, that timing capacitors, which that C1 is now going to charge directly through R1 only, as resistor R2 is being effectively shorted out. Okay, so so there you go. Okay, let's see. An additional diode D2 can be connected in series, like we said before. That ensures the timing cap will only just charge up through D1 and not through the parallel path of R2. It's because during the charging process, D2 is connected in reverse bias, blocking the flow of current through itself. So students will understand what this means. So what they'll do is they'll do some initial hand calculations with some values, okay? Then what they'll do is they'll simulate in PSpice, and they'll actually physically build the circuit and take measurements with equipment. So this has worked pretty effectively in the classes that I teach, and hopefully you can use some of these methods in your classes if you're not doing it already. Thanks.